Okay, after that quick tip, I think we're ready to dig into our demand-driven work order planning. And what I'm seeing a lot is that people want to plan components based on forecasts, but they don't want to release the finished good or the saleable item work order until the customer order actually arrives. And there are a lot of reasons for this, but I think the biggest one is that once you build up and stock an assembly, those components are not available for any other configuration. So the ideal way of doing this in a lot of instances is to go ahead and plan all the components, have them on the shelf, and then when the customer order comes in, to go ahead and get it started down the assembly line or the production line, as long as the customer is willing to wait that assembly or production lead time. Okay, I don't want to get too hung up on giving a formal definition to this. We could call it assemble or make to order. However, a lot of times there is a sub-assembly that you also don't want to get started until the customer order comes in. I'll give you an example just because it's relatively fresh in my mind. As somebody did some processing on shaft or something that then based on customer order specifications, they would pull it out of stock and polish it to its final specification. All right, so in this instant, you have a multi-level facet. So can't necessarily just call it assemble or make to order. So we're going to give this the moniker, I guess, just for the rest of this presentation, is NS or non-stock / make to order. If you're okay with that name, we'll move on. And we'll go into the reasons that some of the standard JDE solutions that they have for this sometimes don't work. Of course, all of them work in certain instances, but what I found is, at least in the most recent times, I've had to stick with work orders. So let's go through the list here. First of all, there's an MRP planning fence rule, which is how you tell the system to interpret demand. There's one that gives you the option to only look at customer orders. The problem with this is it doesn't plan enough material because you don't see any demand until a customer order rolls in. Okay, the next option is line type W sales order. Well, it's pretty strong in that as soon as a customer order comes in, the system automatically generates a work order header for you for the line item on the sales order. I guess what sometimes doesn't work is that it's kind of only single level. You're getting a work order just for the parent item. And if there are related sub-assemblies underneath there that need to happen at the same time or in the same quantity or to the same specification, you kind of have to wait until MRP runs to see that demand and then generate a planned order. So you can be easily a day behind. Another option might be demand flow, and that's the relatively new functionality. Let's call it, in one flavor, orderless production. And as soon as you think about not having a work order, some companies are not able to use this, and it is kind of interesting to me how many companies use work order headers as a hub to hold transactions such as labeling, serial numbers, etc. So demand flow doesn't always work. Another option might be for our non-stock / make to order is configurator. Well, sure, it's multi-level and it does a lot, but as we know, if you've ever tried it, it's a huge investment in time and effort. And if you only have this business case in a relatively small segment of your company, then you may not want to go in that direction. Sales order kit. Originally, when I prepared this slide, I said it really needs no explanation, but I amended this and put, well, it's not really a manufacturing process. You don't have a work order that for traceability you might require. So anyways, there's probably a lot of other reasons to avoid kits. So what I've settled on as a solution here is to insert up front an extra MRP job, plan generation, a separate version, which only reads these special non-stock make-to-order items and their sub-assemblies, immediately followed by an automatic work order release, then followed by the regular MRP for all items. All right? And what you end up with then as a job stream or a process is step one, you run the job that I mentioned, and I'll show you the setup in a slide or two. It's gonna read only the customer orders in multi-level format, by the way. Then we set up a version of R3411, the auto release, to process those work orders. And these two jobs, between the first one and the second one, I'm going to throw out there might only take a half an hour for the entire company, because it's not all items. But that needs to be followed for regular planning and to pick up where the first two jobs left off and plan the rest of the components based on the full forecast. You have to run a regular MRP, just your regular old MRP. And you know that can take hours, or I think the record that I know of, I was at a company, MRP ran for 23.5 hours. Okay, last thing to consider is once you run this, let's call it regular MRP for all items, in the gray bubble here, it's saying that you're going to ignore those messages because you set up a process in which the system automatically plans those items based on just the customer demand. It's already acted on the work orders and released them, so there's really nothing left to do in terms of looking at those. And if you did look at them, you might be confused because what it's showing you is based on the forecast quantities that are needed to drive through to drive the component requirements. Okay, let's go through the actual setup here. Our case is to set up item 2200 as a buy to forecast, make to order. Man, I heard this one company just drill that into me, okay? And it does make sense. We're going to buy the components to the forecast. We're only going to release the top level work orders when the customer order comes in. Okay, so the system is going to plan a releasable set of work orders based on the customer orders coming in. Then the system, if there are any sub-assemblies, and for purposes of example, our item 2203 and 2204, the tube and the plunger, let's say that you have to kick those off at the same time. And then again, components, to finish up this case, other components are going to be planned based on the forecast so they can be ordered, placed into stock, and they're ready for when the customer order does come in. The setup involved here is first give yourself an address book record to identify a group of items, give it a planner code, and here we're just calling it the MTO planner code. It's a generic or logical type of code. We're going to use that in our data selection. We're going to code both the parent item and the sub-assemblies, run them all at once in that abbreviated look at the plan. And then later on, we run all items in the regular MRP. Okay, one of these keys is we talked about a planning fence rule of C, customer orders only. Showed you why that didn't work. What we're doing in this solution is we're actually looking two different ways at demand: customer order and then also forecast. So we need a rule that's going to work for both, and G definitely fits that need. Okay, so we've got our parent item set up. We're also going to set up our sub-assemblies, 2203 and 2204, going into that bicycle pump 2200. We code those because we run all those items together, and our special MRP run reads customer demand only, creates planned work orders, drops down a level in the bill of material to these sub-assemblies, plans only what's required for these subassemblies and gives planned work orders for those.